Hello, everyone. My name is Daria, and I am going to talk about indexing, and specifically indexing using decentralized data layer. So as blockchain has evolved from being used as solely peer-to-peer technology into something that we use as a global execution runtime for dApps and also for many industries, we face more and more scalability problems. So first one is that amount of on-chain data is increasing exponentially. Also, the data is getting more and more fragmented and spread across multiple chains, and smaller chains are not always supported by centralized providers or the graph. And paying for RPC or running a node is very expensive. So at Subsquid, we tried to solve this problem by building a Subsquid network, which is a peer-to-peer data lake for Web3 data. So Subsquid network is infinitely horizontally scalable because new nodes can join as they wish. It also provides permissionless data access without gatekeeping. It provides credible neutrality. Since there is no barrier for new nodes to join, the queries are trust minimized, and it has a very low maintenance cost, and for the client it is practically free. So let's look into how it works. We have a permanent storage which is decentralized, and it's storing all of the indexed blocks. And we have workers, and each worker is responsible for a subset of blocks. So when we want to query the network, we would first decide that we want to query data from a certain block. We will send a request, and the client will return us the worker that has the desired data set. And it will connect directly to the worker and request the data chunk from the worker. We are planning to do the validation by proof of authority. So only whitelisted entities can provide the data for the network. We are also using optimistic on-chain approach, so anyone can submit a proof that the response is not right for a query. And also we are planning to validate it by off-chain ZK proofs that are going to be validated on-chain. So next we have network access. To access the network, you can use public or local gateway, and there is no special hardware required. You can just use your computer, and also there is no sync time. So you can query the network, and it provides a more granular API than JSON RPC methods. You can request a very granular data, not just the block. You can request only transactions or only logs. Historical data is completely free, and also you can fetch multiple blocks in one call instead of doing it one by one. So the process of querying the network would look something like this. You would start a local gateway on your machine, and then you will request the current height of the archive. Then you will request the worker ID for the desired block, and then you will query the worker through a post request with your query. So let's look at how it works when we start up the local gateway. You can see that we start at 0 blocks, and then we get pings from the workers on the network. And next, if we want to, so let's say we want to see the transactions to the Vitalik's wallet from a certain block, our query would look something like this. We will specify the address. We can also choose the fields that we want. So in this case, we want to see the hash, transaction origin and input, and we also are asking for gas used in the block. So this would look something like that. We will first ask the network to give us the ID of the worker that has the desired data, and then we will send the query, and it will return the data set. So this is the example response that we'll get from the network. So as you can see, we got the transactions and all of the fields that were requested. This is continued response. So now I have a video. You start at 0 blocks, and then you get pings from all of the available workers. And you can see that we'll very quickly get to seeing all of the blocks up to the last indexed block. Okay, so now we are at 18 million, and that took 30 seconds. And then we have the second video of how it looks like when you send the query. So we send the query, and then we get the worker with the ID, and we get the data returned to us. And this is how to use the network directly through its API, but you can also implement a subgraph adapter, and we did just that. So it would work just as simply as running a service. So you'd have your normal subgraph running, but instead it will also depend on the query gateway service. And we'll run a query gateway service on a local host, and instead of okay, so here you have the graph, and you can see that it depends on the query gateway service. And here we have the query gateway service that runs on the local host. So our subgraph uses the query gateway as the data source instead of an RPC, so querying it is completely free, and you don't pay anything for the query. So that's it, and here we have the link to the white paper about the network. What do you mean, kind of queries? Anything that is on chain we have. So you can do logs, state diffs, traces.
Done.